Now let's explore finding lengths of segments when there are two secant segments that are intersecting. Now notice the secant segments will be intersecting outside the circle. Here's the intersection point. We labeled it similarly to the one where we had the chords. Now what's important to remember is that these formulas are no different. If the intersection point is E and the points that touch the circle on that secant segment are A and B, we do AE times BE and then equals. And then we look at the other segment, in this case the secant segment. The 2 points intersecting on the circle are C and D. So CE times DE. This formula is absolutely no different than the chord formula. The important thing to know is it's the same formula, but how to use it may be slightly different. Let's see how this formula applies to secant segments. AE is this external segment of the secant. AE is the external segment. What is BE? BE is this entire way across. So this is the secant segment. What it's called isn't as important as how to use the formula. All of the parts in my formula have to touch the intersection point, have to include the intersection point. The external segment includes the intersection point. The entire segment includes the intersection point. I never want to say just this chord because it doesn't include the intersection point. For similar reasons of the proof that I showed you above, it's similar triangles that prove why this is true. CE is the external segment, CE, and DE is the entire secant segment. Let's look at how to use these formulas in the following examples. Find the value of x. So here's my intersection point outside the circle of these two secant segments. Let's start with the top secant segment. The external segment that touches this intersection point says 4. So I write 4 times. Then I also have to touch this intersection point with point B. So all the way across is what I'm looking at. How long is that all the way across? That's right, it's 10. 4 and 6 put together make 10. So 4 times 10. And then I say equals. And now let's look at the other secant segment. So touching point E is this external segment that says 5. Touching point E is this entire secant segment that says, well, we have to do a little work here. How did we get the secant segment on top? We added 4 plus 6. So how can I get this one? We add 5 plus x. We write it as 5 plus x. So if I have to multiply 5 times two numbers, I'm going to say, in parentheses, those two numbers added together, 5 plus x. Now I solve this equation. 4 times 10 is 40. Distribute the 5. 5 times 5 is 25. 5 times x, 5x. Now we can subtract 25 on both sides. And 15 equals 5x. We can divide both sides by 5, and 3 equals x, but it's better to write it x equals 3. You want to give a shot to number 4? So let's see how it went. This one, I left off the labels. So here's the intersection point out here. I usually like to highlight that or make sure that I notice that's the intersection point because all the parts of my formula touch that intersection point. So I have the external segment out here, 3, times the whole secant segment because I have to touch the intersection point. 3 and 6 put together make 9. So 3 times 9 equals, let's look at the other secant segment. The external segment is x. The entire way across, the secant segment is x plus x, 2x. So times 2x. I don't put parentheses when I don't have plus there. So on the left, 3 times 9 is 27. On the right, 2x times x is 2x squared. Before we deal with the squared, I divide both sides by 2. So x squared equals 27 divided by 2. If I could do that evenly, I would, but it doesn't work out evenly here. Then I need to take the square root. So x will be whatever the square root of 27 over 2 makes. We could practice simplifying that, or we could practice rounding that. Using our calculator, we get about 3.7.